sensor reading data. So on our project overview, what we will see is how the model was approached, identifying the regression task, all the sensors features selected, the algorithms that were considered, and feature justification via correlation analysis. Then the model building, how it was tested, how it was split, and also how both degrees were compared, and the model evaluation, the metrics used, and how the final model evaluated the held out test set, and the model interpretation about how the variance was explained, the average prediction error, and also any domain driver data. So here is a screenshot of my model that was made in Excel. What's task identification and feature selection can be shown how we have the descriptive studies and also the Pearson's correlation matrix. The algorithms that were considered were the multiple linear regression and a polynomial regression. What we have as a regression task would be the target PE that is continuous and it goes to a regression not classification. And the evaluation metric would be our RMSE and interpretable with MB units. And the features used were all four features: retain the AT, the BAP, and RHR. And AT has the strongest correlation with PE, one from minus 0.95, and B also strongly negative with an R from minus 0.87, and an AP and RH have weaker but meaningful signals. In the model building, I made a train test split cross-validation strategy where we had a data split of 80% training and 20% test, and the test set was locked, never seen during the model selection, and the validation strategy. So we have 5 folds CB applied on the training set only. Each fold had about 6,123 train and 1,531 validation samples. So all 5 RMSE scores were average for the stable estimate, and that would to prevent overfitting to a single validation split. So we have here the parameters, the rationale for the validation strategy, and we have the number of rows given the data set from the course and the test held out also for the rows, and the random C that was out of 42. Then we had also part of the model and the polynomial regression that had a 5-fold CV comparison, and we have here the graph as it shows both comparisons, and we have how it goes for the vacuum, the AT, the temperature, and the pressure AP, and the humidity RH. So we had a bit of a small positive effect for AP and a negative effect for RH, and also the linear relationship with the quotation formula and how it was simple, interpretable, and had a strong baseline as result. And the selection rationale was a poly degree 2 achieved the lower CBRMSE across all 5-fold consistently, and that was the one that was chosen as the selected final model. Here are some screenshots of the final model performance and held out test set. So we have here how the data graph is showing all of the combinations and the distribution in here, and the main thing would be about our 4.23 MW, that was the root mean square error, and a 93.8 variance explained with a strong predictive power, and a 3.35 MW that was the mean absolute error, average magnitude of error, that are good stats. And this was chosen because it was directly interpretable, penalizes large errors more than MAE, and it was desirable for energy forecasting, and also differentiable standard for regression optimization. What the results tell us is that we had a good combination for the model, getting good outputs in a poly degree 2 for output prediction. Here is a summary of what was tested and the key takeaways of the graphs. And we had as a result the strong predictive power Practical small errors, they were really a good margin to work with, and no systematic bias, and also a dominant driver that was the temperature coefficient. Um, as we have a high temperature and high vacuum, efficiency drops non-linearly. So a polynomial can capture this and the MLR cannot. So we are sustaining two types of approaches to compensate the strengths of the model. And how the polynomial, of course, fits the MLR. And as a summary, we have the modeling approach that was correctly identified as a regression, all four features used, and we used it to test both MLR and polynomial. That was the one that won, and regression considered. The second was the model building, two models compared by a five-fold CV, and we have the polynomial degree 2 selected based on lower CV RMSE. The model evaluation, the last one also chosen as a primary metric and evaluated and held out to 20% test. And the model interpretation, we have a 93.8 variance explained with minus 1% error, well, minor than 1% error rate. So the temperature was a dominant driver and no systematic bias in residuals. And thank you so much. I hope that it was interesting project for you guys. Thank you for reviewing.